Hi, I am Gunn, Assistant Professor in the Department of ECE in JSREC Engineering College. So now I am going to discuss about the test and setup about the VI cases of Gunn diode or we call Gunn effect. So here we are having the test and setups. First we are having a Gunn power supply unit. So you know very well. So it's going to act as going to feed a power supply or bias to the Gunn unit. So in this, initially you are going to keep a modulating frequency as a minimum position, then again pin bias as a minimum position, and also Gunn bias as a minimum position. Next, you need to choose the which type of mode you are going to choose. So in this, we are having continuous wave mode, PVC data mode, and again interference mode. So we are going to only consider about a continuous wave alone. So you just keep a mode as a continuous wave section. So next we are having first Gunn oscillator. So it's a Gunn oscillator diode. So it's going to generate the microwave frequency by the help of the applied Gunn supply unit. So it depends upon power supply, the Gunn bias which is going to emit the microwave source. Next to that, we are having pin modulator. So you know very well about the pin modulator. It is a P-type intrinsic and N-type material. It's a pin modulator. Next, it's about the isolator. The purpose of isolator is about it's going to block the mismatch signal which is get reflected back from the termination side. So if there is any mismatch conditions, the isolator is going to help. It's going to block. It's never going to allow the reflected signal back to the source region, so that the entire section will be get in a safe mode. So it is like a one-way direction. So you cannot get back. Only it can allow the signal from one end to another end. It will not always allow it never allows from the another end to next end. Another, we are having a variable frequency meter. So you know very well in a laboratory purpose we are always having around the value of 8 to 12 gigahertz range of frequency. So we are having a different scale level from lower to higher level of frequency ranges. So next we are having a variable attenuator in the range of 20 decibel. So you can control up to 20 decibel range of signal from the source side. So the attenuator, it helps to, you can change the power strength value from the source side. So you can vary, you can control how much of power it is need to the output end, or maybe it's called a termination end. So it is a variable attenuator. Finally, you are having a detector node. So the name itself indicates it's going to detect, it's going to find the signal which is generated from the source side. So the detector, what it's do, it's going to collect the Gunn signal from the source side. It finds the signal and it's feed to the another portion, or maybe called the output portion. So this is the output section. Either we can go for SWR meter, or maybe you can also deal with DSO also. So here I am going to show about a SWR meter. So SWR, it's about a standing wave ratio. So in a microwave signal or maybe transmission line, standing wave ratio is very important. So you should keep the SWR value as close to the 1 value, right? So if the SWR value is getting rise, this leads to 1 to maybe high. It is not, it means that the transmission line or maybe the power section does not match perfectly. We always care about a SWR meter. It always having a close to 1 value, that is a minimum value it always reflects. Then also we should keep the gain in a mid value. You have a mode of selection also. It's have a normal mode, audio mode, and again PC interface mode. So we are only going to having a selection of normal mode alone, and also having a range of decibel what you are going to focus. Depends upon power value, you can change the decibel values also. So it is depends upon power section, you can change the range. Then again you are having decibel or SWR value, you can change the decibel or maybe SWR. So these are the SWR meter section. Next I am going to discuss what is actually a Gunn effect, right? So there is a VI characteristics of Gunn diode. So when you changing the voltage from minimum to maximum, and also the voltage start from lower to higher value, if you are keep changing, if you are keep varying the voltage, simultaneously the current also get increase, right? So the voltage is get increase and also current will get increase. But after the reaching the threshold voltage level, the current cannot increase further. So it does not increase, instead it going to decrease. It's going to decrease. That means the flow of electrons, that the current value get decreased, it get minimized after reaching threshold voltage, that is called a threshold voltage, right? So this region is called negative resistance region. So the negative resistance region is very important. That is the actual region where the diode is going to emit the microwave sources. So after the reaching threshold voltage, the current will get decreased. At the point of decrease section only, the Gunn, that is called a Gunn diode, will going to emit the microwave sources. So this is about a VI characteristics of Gunn diode. So it is very important. So you can it has a main